Kia ora, welcome to Alkenes, our new functional group. So, like alkanes, that they only contain carbons and hydrogens, but they contain one or more double bonds. Cool, so our simplest alkene is ethene, so we've got two carbons and they are doubly bonded to each other. Note that that carbon has only 3 regions of negative charge now, hence that 120-degree angle I've drawn there. So like alkanes, if you add more carbons to your chain, you will name them accordingly. So I've just drawn out here number of carbons 2 to 8, ethene, propene, butene, pentene, hexene, heptene, octene. So those same prefixes, but now they all end in -ene. This indicates we have alkenes. So going in and drawing propene, 3 carbons, and I'm just adding all the hydrogens in so that each carbon has 4 bonds to it. Same with butene. Okay, 4 carbons, first 2 have a double bond, and I'm just adding in the appropriate number of hydrogens so that each carbon has 4 bonds. Now you try it with the next 4, pentene, hexene, heptene, and octene. So you just need to put 1 double bond between the first and second carbons in a straight chain. Awesome, so your pentene and hexene should look like this. You got my 5 carbons in pentene, 6 in hexene, double bond between the first 2 carbons, and I've just put in enough hydrogens. Now I'm just showing how you can break it apart and write a condensed structural formula. Pause here and figure out the molecular formula. So pentene, I'm counting it up, I've got 5 hydrogens and 5 carbons and 10 hydrogens. Hexene, 6 carbons and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogens. So our general formula is then CnH2n, twice as many hydrogens. That's the general formula for alkanes. So what if I put the double bond somewhere else in the molecule? For example, butane. So it's based on 4 carbon structure. What if I put the double bond between the second and third carbon now? So drawing out my structure, is it still called butane? Well, let's have a look. It's still got the formula C4H8, but it does look different, right? It is an isomer because the double bond is now between the second and third carbon as opposed to before where we had it between the first and the second. So we call it but2ene because the double bond is on the second carbon. So try this. Draw the structure of pro2ene and pause here. Cool, so 3 carbons and I've just labelled them 1, 2 and 3 and I put the double bond between 2 and 3. So my question is this an isomer of prop1ene? No, it's just turned around. It's actually exactly the same. So you can only start moving the double bond and forming an isomer once we have 4 carbons, so from butane. Okay, try this. Draw pent2ene. Then draw pent3ene. So I've just drawn pent2ene, double bond between the second and third carbons, and pent3ene, drawing the double bond between the third and fourth. What you'll notice is that these are actually mirror images of each other, so they're the same, but only one name is correct. And you guessed it, it's pent2ene.